Good morning. Today we are going to see the topic on unused transmission capacity. That means UTC method in the restructured power system. In restructured or deregulated power system, the transmission network is shared facility used by many market participants. Say, for example, GenCos, DISCOs, and traders also. In unused transmission capacity method, it is one of the transmission pricing method which allocates the cost of the unused available transmission capacity and which ensures full recovery of the transmission infrastructure cost, and also it accounts for the congestion and as well as the security constraints. So unused available transmission capacity, that also it allocates the cost and ensures the full recovery for transmission infrastructure. Because if the transmission you're owning the transmission towers infrastructures, okay, say for example one part of the transmission towers alone you're operating, other parts you're not operating, means automatically other parts also, because there also you need to pay the salary to the employees who are working in that part. So there again you need to give the salary to that part. So some cost is allocated for unused transmission capacity also. So which ensures the full recovery of the transmission infrastructure cost and accounts for the congestion and as well as security constraints also. It accounts for, okay, this pricing method. Okay, even transmission line is not fully used, it cost must be applied, cost must still be paid for. Okay, so that also there. Even one part of transmission line is used, other part not used, but even though you need to pay for full. So that this is the definition for the unused transmission capacity. The unused transmission capacity UTC method allocates the cost of the available but unutilized transmission capacity among the market participants based on their system impact, which ensures fair cost recovery and efficient congestion management in the restructured power system. Why UTC method? That means unused transmission capacity method is needed, because some users reserves firm transmission capacity. Okay, firm transmission capacity, and remaining unused capacity headroom still exists. Okay, if unused capacity costs are not allocated, transmission owners face revenue shortfall. As I said, because they are own, because they need to pay the rent for that particular place where the transmission tower is placed. Even though unused or unused, that also they need to pay the rent for the tower, tower place, and as well as the salaries to that particular employees. So there also we are facing the revenue shortfall. So network investment becomes unattractive. Okay, so these are the problems. So that's why this UTC method is used. So mainly the key idea of this method, not only the pricing is used, allocated for used capacity, but also unused capacity should be priced fairly. Some amount should be kept for unused transmission lines also. So, just what is the core concept? Think of the transmission network as in the as a highway. Okay, just compare the transmission network as a highway. So, firm contracts are nothing but vehicles already on the road. Unused capacities are nothing but empty lanes. Okay, so empty lanes still cost money to build and maintain. Yeah, it is obviously, because the empty lanes, say for example, all the roads are utilized by, owned by some private sectors. Okay, so they are collecting the toll charges, no? So similarly, like that, even though the toll charges, how they are collecting, say for example, some 30 kilometers of that distance, or some 15 kilometers of that distance. They need to maintain the whole roads, and who are all working background in the toll plaza. Everybody they need to pay, and capital cost, initial cost, even though vehicle running or not, some flat rate tariff will be there in the toll gate. Similarly to that, here empty lanes still cost money to build and maintain. So UTC method allocates the cost of these empty lanes to all the users who benefit from this system. So what are the key terminologies in this particular UTC method? Means, first of all, you need to know what is total transfer capability. Okay, total transfer capability, TTC, is nothing but maximum power that can be transferred safely. And you need to know this term, existing transmission commitments, ETC. That means power already commitment under the firm contracts. Okay, that is the existing transmission commitments. So what is this ATC, available transfer capability, is nothing but availability transfer capability is equal to TTC. That means maximum power that can be transferred safely, minus ETC, that means existing transmission commitment, that means power already committed under the fair loads, minus the reliability margin. Okay, reliability margin also you need to minus. So this is the formula for calculating ATC, available transfer capability. Next, now we are coming to unused transmission capacity. Unused transmission capacity, that means UTC. So what is UTC? UTC is nothing but total capacity minus total transmission capacity minus used transmission capacity. Total transmission capacity, for example, I'm having 100 kilometers of line. So used capacity is only for 80 kilometers. So that is nothing but unused transmission capacity. That 20, 100 minus 80 is equal to 20 kilometers is unused transmission capacity. So for that also I need to charge some firm amount, some small amount. Okay, some small amount, such that the transmission owners will not be in the loss. Now, step by step, how UTC works. Step one, first we need to do the system power flow analysis. Perform either AC or DC load flow analysis. Next, identify line limits and as well as the congestion. Line limits, how much line that limits can handle, how much transmission capacity that a transmission line can handle, and also congestion limits. Next, after that, step number two, calculate ATC, available transmission capacity. So available transmission capacity, which determines how much additional power can be transferred. How to calculate ATC? ATC already there, TTC minus ETC minus reliability margin. Now, step number three, identify unused capacity. How to find out unused capacity? Compare the line capacity versus actual usage. Okay, so total line capacity minus the usage, actual line usage. That one you can easily get the unused capacity. Next, impact assessment. Use the power transfer distribution factors. These are also called PTDFs. Okay, power transfer distribution factors. So this factor is used to calculate the impact assessment. Determine how each transactions affects line loading. That also we are calculating. How each transaction affects the line loading. Say for example, light time also there. Say for example, if you install the transmission line, that conductors and all you can use based on the number of operating hours. Okay, some 10,000 operating hours or 1 lakh operating hours. After that also you can use what happens, the skin effect, the formation of skin effect will be more like that, because what happens, that the conductor AC is a conductor, aluminum conductor, steel reinforced. Outside of the conductor will become like polished. After that, you can get more skin effect will be there. Now, then you need to replace the that lines. Okay, that is also there. So that impact assessment also that we are calculating based on that some cost we are keeping. Next, cost allocation. Allocate the cost of unused capacity to the generators. Okay, generators also, loads also, traders also. So based on benefit or impact. So these are the some of the cost allocation. Okay, so generators, unused generators also has to be paid, no, because there are also some few employees are working, even though resource is not available, they are owning. So few because not fully, some few amount has to be added. Next to load, so say for example, you are generating the this much 100 megawatt, but load is only 90 megawatt. 10 megawatt is more, you are generating more, then who has to pay for that? Generation companies can't bear because they are spending. Here thermal generator units are costly, so what they will do is they will increase little bit amount in the from the consumer only, then they will charge that also. And traders, power traders also, based on that, so based on the benefit or impact, that is also cost allocation is there. So this is a conceptual block diagram of the unused transmission capacity. Okay, so first transmission networks like line limits and constraints that we need to choose. Next, we need to do the power flow analysis, either AC analysis or DC analysis or security analysis. That also we need to make. Next, we need to calculate the TTC, total transfer capability. Okay, next we need to calculate the existing commitment transmission commitments. That also we need to calculate. That is ETC. Okay, now we need to calculate the ATC, available or unused capacity. Okay, available or unused capacity. That is nothing but UTC, that is unused transmission capability, is equal to TTC minus ETC minus that reliability margin also. That already we have seen. Okay, now cost allocation using PTDFs to the market participants. That also we need to make. So this is the simple conceptual block diagram of unused transmission capacity, that is UTC methods. Now, what is the role of this PTDFs in UTC methods? So, what is PTDF? That is Power Transfer Distribution Factor. So, which shows that how transactions affect the flows on the each line. Okay, how this power transaction affects the flows in each line. Okay, so that PTDF, where it is used now, it identifies who cause congestion, which part causes congestion. Based on that, they will be charged congestion charges more. Okay, so which part, say for example, some part B, part B of that particular bus is causing congestion. So that part B of that particular substation will be charged more congestion charges. Allocates that, and PTDFs used to allocate the unused capacity cost fairly. Okay, that also unused capacity cost, some cost, fair cost we need to. Next, PTDF used to prevent pre-riding. Somehow they are using some free power. Sometimes they will use free power. So free power can be easily identified where the power usage. We know the power usage as a whole, but sometimes they will use some hooks in the remote areas, and they will utilize without intervention of that particular operator. So that also for them also some penalty tariff also we need. So this factor will gives you the free riding also will be prevented. So now, based on that, we are going to solve a simple problem on the this UTC method, unused transmission capacity method. Okay, such that you can easily understand. First of all, line capacity we are taking as 200 megawatt. Next, usage, firm usage, we are taking as 140 megawatt. So how to calculate this UTC? UTC is nothing but total capacity minus usage capacity. So total capacity is what? 200 megawatt. And firm usage is what? 140 megawatt. So 200 minus 140 is nothing but 60 megawatt. 60 megawatt is the unused capacity. That is UTC, unused transmission capacity. So the cost of the line is, say, for example, 6 lakhs per year. Okay, so the cost per megawatt of unused capacity is nothing but 6 lakhs divided by 60. That means this is the some fair cost. Okay, that is 10,000 per megawatt unused capacity. Okay, so you need to pay 6 lakhs plus this 10,000 megawatt for the unused power also. So this cost is allocated to the users based on the PTDF impact. Okay, so this is also there. What are the main advantages of this unused transmission capacity, that is UTC method? So which ensures the full cost recovery. So there will be no losses to transmission uh, company owners. Okay, because it ensures the full recovery cost, and which promotes the non-discriminatory access. Okay, so there is no discriminatory to any one generator companies or to say transmit the power like that. So it is open to everyone who are generating power. So it promotes the non-discriminatory access, and also it handles the congestion realistically. Okay, realistically can handle the congestion, and also encourages the efficient grid usage. Okay, and also it supports the long-term network investment. Okay, so these are the advantages of the unused transmission capacity method. What are the main limitations of unused transmission capacity method? Is nothing but computationally intensive, because more computation is needed and it requires accurate system data, and the cost allocation can be complex. Okay, cost allocation can be um, complex, difficult for small systems. Okay, small systems very difficult, we can't calculate. So these are the main limitations of this UTC method, that means unused transmission capacity method. Now we are comparing this unused transmission capacity method with other methods, that means postage stamp method, megawatt mile method, MVA-Mile method. What are the methods we have seen? So, with respect to congestion and unused capacity and fairness, if you take the postage stamp method, congestion not considered and unused capacity also not considered, fairness is somewhat low. Okay, low. So, if you take the megawatt mile method, the congestion we are considering partially, unused capacity also not we are considering, and fairness is medium. If you take a megawatt mile method, congestion we are considering partially in megawatt mile method, unused capacity is not at all considering, and fairness is high. But if you take the unused transmission method, capacity method, UTC method, even we are considering congestion also we are considering, unused capacity also considering, and fairness is very high. So the most of the transmission companies, they will use this UTC methods, because to avoid them in the losses, because otherwise the transmission companies will be in the losses. Okay, so they use this UTC methods for their cost collection method, for their cost um, transmission cost method. Okay, this is the comparison with the all other